Through the various researches related to the past and the present, we can foresee the future of the year 2050. Air pollution will become a threatening issue to all living creatures on Earth. Also, the drinking water will not be enough to provide the world's growing population.
High level of carbon dioxide causes the sea level to rise. Fossil fuel shortage has increased the attention for renewable energy development, such as wind, biomass, ocean tide wave, solar and geothermal energy. Urban population density is expected to rise rapidly along with the general population.
This cylindrical growing system allows for bountiful, healthy, and nutritious agricultural products all year round in a limited space. Revolutionary rotary hydroponic systems are used for convenience, simplicity, and maximum yield in mind.
In the era of fusion technology, the individual transportation vehicle will allow for maximum flexibility. Motorways will be liberated from the ground and exist on the land and in the air.
Base isolation system produced by the THK shows that the TSD table protects fragile objects during the earthquake. The base isolation system allows for the building mass to have both vertical and horizontal structural stability, resisting the vertical gravitational load and horizontal seismic and kinetic forces.
Jersey City, one of the state's fastest growing cities, is developing its own impressive skyline and economic engine. Also, rehabilitation efforts have already begun and are being led by the Journal Square Restoration Corporation and the Jersey City Economic Development Corporation. From 2030, near Journal Square area will be filled with massive buildings, except above the railroad. The trains will be replaced with air devices, so we propose that redesigning the railroad space as like High Line in New York City. We can generate not only place which can be occupied by tenants, but also energy supporting green connections between cities.
As we have shown on our adaptive matrix, tree is the most optimized system for self-sustainability. Our initial approach and design process was literally to make the building a tree. Through the pixelizing the tree into various scale, we were able to achieve a different color configuration. By mixing these different conditions, we were able to come up with the logic that structure our power plant. The small pixel would maintain close relation to natural system, such as solar collection, vertical farming, water collection, and so on. Large-scale modules which further diminish from the natural system would be the location of the mechanical systems that allow for the building to collect energy mechanically from the nature. The section of the building would maintain its depth and slide on top of one another. These compartmentalized flexible systems would allow for the building to adapt to and optimize its function according to the climatic conditions. Also, the flexibility would allow for the portion of the tower to accommodate social programs that would allow for the power plant to adapt and create both contextual and social relations. Complex organization of power plant systems, residence, and sky garden, the project demanded an additional logic to make its coherence with the internal and external relations. In order to allow the power plant to have both structural stability and observe the natural energy, we have developed a skin system that changes its opening and density of its enclosure. The hexagon grid with the scale change allows the units and the building to have surface conditions that react to the programmatic demands. Large hexagons would form a performance density along the units and surface conditions that demands for maximized solar gain and with connection to the nature. Also, the large hexagon units would allow for access for the public within the building, which becomes an opening for the sky garden, the residence, and public areas within the building. Small hexagon units would not only build solid surface on the unit, but also allows for series of conformation of the surface conditions that could become the wind scoop or other functional relationship to its internal programmatic functions. For example, the solid surface conditions in this diagram would allow for the wind to channel into the wind turbine and also to have functions such as storage or mechanical systems that demands to be protected from the external conditions. Next is a strategy to reconnect and adapt the power plant to the dense urban conditions. Power plant, which is intended to supply the neighboring buildings and the city with energy and resources, would demand a system that absorbs and distributes sources efficiently. Flexible tubical core systems placed on the exterior of the building would directly plug into the surrounding buildings and provide with the sources. Also, the core would meet with the city main power lines to distribute its collected energy and sources throughout the city.
With Jersey City changing to high density, it demands for higher energy agricultural production, water, and oxygen to meet the increasing demands. Flexibility of the tower allows the power plant to change and adapt to environmental conditions to optimize its performance. GreenGiant placed in the heart of the urban context will not only provide energy, but also generate various social programs within to adapt to its urban context.